Yo, technology. Can you can you see my screen now?
Yes.
Where did the interference start? Is it at this
From the
integral
integral
or
of 1 2 sine squared x plus cos
this one?
4 cos. Yeah.
Here.
Yes.
Okay. Can I start from here now going forward?
Yes, sir.
Okay. So I'm so sorry about that. So it means that my Bluetooth is on the laptop, and then they are using the headphones in the other room doing whatever they were doing. So that is why now you were hearing them instead of me. Right. So I will do it again from the beginning. Now, this is what I said here. That this is example 1. I will do this example the way I expect you to do it in an exam situation, because in an exam situation, you guys are fighting for also time. In the textbook, the study guide, it is done correctly. There's no issues there, but the method that they use is long, because they do the substitutions separately and they bring them back to the integral. I will do everything all at once, but I always need my toolkit. My toolkit is this rectangle that you see on your far right. So which means in an exam situation, you will go there and immediately you see a question like this that has got different coefficients, but the cos squared and the sine squared, you know that there is no way in which you can use identities, which means immediately it must come to you t substitution. With your t substitution, you come and write down your tan x is equals to t. You draw your right angle triangle the way we did in the first slide, and you go and plug in the opposite side as t and the adjacent side as 1. Then you go and use Pythagoras to find the hypotenuse. After you do that, then you define your sine, you define your cosine, and you do your derivative to get what will replace your dx. So you will have this all the time next to you when you want to solve a question like that, this one. Now, in the next step, it's just a matter of substituting equal quantities. The first quantity that we substitute is sine x, which is equals to t over square root of 1 plus t squared. And now that is put here inside a bracket. And the power 2 is this square that is there for the sine. And you do the same. Your 2 is still this one, which is the coefficient of sine squared, which is there. Your 4 as well is there. And your cos x, you replace it by its equivalent quantity, which is inside that bracket, but it is squared. Now, the dx now, on the bottom here, you find that your dx is replaced by 1 over 1 plus t squared dt. Now, this is in place of dx. There it is inside that bracket. Now, the next step is now coming after you square this value. When you square this value, you will get t squared all over 1 plus t squared, because the square root power 2, they become half times 2, which is 1. So what will remain at the bottom will only be 1 plus t squared without the square root, because the square root cancels with the power 2. The same applies here. 1 squared is 1. The square root of 1 plus t squared is equals to 1 plus t squared only. Now remember, you've got now another fraction that you are multiplying this with. That fraction has got the numerator 1. 1 times 1 will be 1, that you will see in the next step. Now this 1 plus t squared multiplies this one, which is now 1 over 1 plus t squared. Then 1 plus t squared divided by 1 plus t squared is 1. The same applies this side. This is t squared all over 1 plus t squared. This 1 plus t squared divides the 1 plus t squared that is there, and the only thing that is left is t squared, which is multiplied by 2. So that is why you see here in the first integral, at the top it is 1, which is this 1 times that 1. At the bottom, we've got 2t squared, which is this 2 multiplied by this t squared that is there, and the 1 plus t squared has cancelled the 1 plus t squared. That is why it is not there anymore. This 4 here is the one that you see down here, and also 1 times 4 is 4, and over 1 plus t squared, 1 over 1 plus t squared times 1 plus t squared. 1 plus t squared cancels 1 plus t squared. That's where you get this 4 that is there. I think that is where I stopped teaching myself. Now, let's continue now to see what we have here. Now, if you remember the previous lesson, in the previous lesson, we dealt with integrals that lead to inverse functions, to trigonometric functions and those hyperbolic functions and so on. And those things were done in such a manner that we either have a function of x squared plus a number a squared, or the number a squared minus the function of x squared, or the function of x squared minus a number squared. So we are going to now lean into those integrals. And for us to be able to do this properly in this case, we are supposed to have a coefficient of 1 here, of t squared. That's why we're supposed to take out 2 at the bottom as a common factor first. When we do that, we will get 2 into t squared plus 2. And that 2 that I've taken out as a common factor at the bottom, I take it out of the integral as a half. That is where this half is coming from. Now, if we can take this half and multiply it inside here, we should get back this thing that we have here. Now, if you can look at this square root of 2 squared, if you take square root of 2 squared, you get a 2 here. And you take this 2 and you multiply this with this t squared, you get back your 2t squared. You take this 2 and you multiply it with this 2 that will come out of this bracket after you square, you will get back this 4. So which means that this and this are exactly the same. And the reason why we did this is for us to be able to go and look at those integrals that leads to hyperbolic functions and trigonometric functions, inverse trigonometric function and inverse hyperbolic functions. Go now and look at a rule that is resembled by what you see here. A rule amongst those rules that we just did in the previous lesson that is resembled by what you see here at the bottom. And tell me the rule number corresponding to that one, to this that you see here on the screen. Which rule corresponds to what you see?
25, sir.
Rule 25.
Yes.
And I agree with you, because there on top of the box, indeed, it is rule number 25. Now, I want you to use rule number 25 and do this integral and give me the answer after integration. Remember, your f of x here is now t. The rest, your a is square root of 2. Then you just apply rule number 25 and you give me an answer thereof. Come on, guys. You don't have to take time for this. It's rule number 25. You just plug in where there's a t, it's your f of x. Where there's an a, is your square root of 2. And give me rule number 25, the right-hand side.
It's 1 over 2 square root of 2.
Yes.
Arc tan into brackets f of x is t, which is tan x, over the square root of 2 plus c.
First, give it to me with t only first.
Okay.
Before you replace t with tan x.
It's 1 over 2 square root of 2 arc tan into brackets t over the square root of 2 plus c.
Okay. Plus c. And then, because t, you brought t on your own, you go back here and you do what he just mentioned there of replacing t by tan x. And this is exactly indeed what you are talking about. So the first part is when we are still using t. So according to rule number 25, rule number 25 says f of x squared plus a squared. The integral thereof is arctan of f of x over a. So our f of x is t, so there is t over a, which is square root of 2. How did we get this one? It's the 1 over 2 that we have already, that we put it there, and then the rule says it's 1 over a. So 1 over a, which is 1 over square root of 2, multiplied by 1 over 2, which was there already, give us this 1 over 2 square root of 2. Arctan t over square root of 2 plus c. But t was brought by us, so we must remove it again so that we get the answer as that one, which is exactly what he said. Now, I think I'm done with this particular one, and it's your turn to do this one. Let's go. And I want the final answer after you have done the t and you have replaced it, the final answer in 3 minutes, please. So just to assist you so that you don't have to do this all the time, I've put in that toolbox for you on the screen. So you can use my toolbox. But I'm borrowing it to you for today only. You will have to do your own toolbox yourself. Anyone who gets the answer first, please let us know. The final answer. One minute. Any answers? Five seconds. Any answers? Is it that difficult? Do you need more time or should we do it?
Just 30 seconds, sir.
Can I give it a shot?
Yeah, please do. The final answer?
The final answer is minus 1 over 6 arc cos into the square root of 3 tan x over square root of 2 plus c.
Arc cos. Cot with an
Yes,
H, right?
with an h.
Okay. Is there anyone who have got a different answer to that one? Any seconder? No seconder, no objection, only what that answer. Let's check this answer if it is correct. Or another answer is coming.
Yes,
Yes,
we will
sir.
try, sir.
Yes,
Okay,
bring
go
them.
ahead. Yes, it's 1/3 acosh square root 6t over 2 plus c.
Akposh, cos with an H, right?
Yes, sir.
Yeah. So hey, we have got very interesting answers. Do we have a third one? I must just say this. If you are
Yeah.
not attempting to do these answers and get them wrong, so that when we do it, you realize, oh, this is where I made a mistake. You are not learning. There are people here who are like sitting in a bus to Cape Town who are watching only. They are watching, they don't have a pen and paper with them. They are not writing anything. And they are thinking that after this, they will be able to know how to do these things. It is impossible. The mathematics is like driving a car. If you sit in a front seat and watch a driver drive the car 1,000,000 times, when they say sit there and drive, you will not be able to do it. That's mathematics. And it has nothing to do with intelligence. Mathematics has everything to do with hard work. Done. Now, and the third answer, please.
Yes, sir. Mine is 1/3
Yes.
arc cos with an H.
Posh.
Hush, yeah,
Yes.
and then open bracket square root 3/t squared close bracket plus c.
And that t squared can be replaced with tan x, so it will be tan squared x.
Oh yes.
Yes, perfect. No, it's fine. All these three answers are correct until we prove them otherwise. So I want us to do it together now. So can we please now let's go together. First step is to replace the sign with its equivalent, the cos with its equivalent. The number 3 and minus 2 remain intact. The dx is replaced by its equivalent, 1/1 plus t squared dt. That's the first step, which is this one. This is just a matter of replacement. Now the next step will be now after we remove brackets. Now let's look at what happens after we remove brackets. This one will become t squared over 1 plus t squared. This one will become 1/1 plus t squared. When this 1 plus t squared multiplies both, the 1 plus t squared will be are gone. What is left is 3t squared minus 2 underneath dt only, which is that you see there. Now this is similar to what we had before. This coefficient of t squared will make our will give us a problem. So we must take 3 out as a common factor. When we do that, we get this 1/3 out. And then inside we are left with t squared minus 2/3. That is what is here. Then we want to just rewrite this minus 2/3 as a square. Then it becomes the square root of 2/3 squared. Because when you square this, the square root will cancel out with the half and you will get back your 2/3. Your t squared is the one that I talked about after taking out this common factor here. And that is why we are saying now this is equals to that, because if you square this and you multiply 1/3 inside, you get back here. So which means now this is some rule. Now you go for those people who you have got 3 different rules that you have applied. Now when you are here, go and tell me which rule is this. It's rule number what?
27, sir.
Rule 27. And I'm saying rule 29. I may be wrong. You remember?
Rule 29.
Is it 20? Am I right or wrong?
29.
So you are reversing your 27.
Yes, it's 29.
No.
Sorry, yeah.
So so it means I'm right. So now,
Yes, sir.
guys, apply rule number 29 and tell me what the answer is. So I think a lot of people are common with the 1/3. So a lot of people who have said 1/3 first, I think they are there. But now the challenge is that there should be something about this. So, but the 1/3 is this one, but it is missing the 1/that. Rule number 29 applied. So rule number 29 is which trig or hyperbolic function? Arc of what? Is it arc
Arc,
cosh or arc
arc
coth?
coth.
Coth with an H, right?
Yes.
Right. So it means the causes that have happened, you have messed something here for you to be able to go to rule that you have got cosh. It's supposed to be the one that has got coth. And indeed, this is the answer. Now, this answer, I have deliberately done it in two different ways, and I will explain that these two are exactly the same. Now, firstly, the 1/3 that was there must be here, which is this 3 that you see here and the 1/. Now, according to this rule number 29, it is minus 1/a, if you check that. So that minus, which is this one, and now our a is square root of 2 over square root of 3. Now, it means 1/that will be the other way around. It will be square root of 3 over square root of 2, which is this square root of 3 over square root of 2 that you see there. That is your 1/a. And this 3 is the one that was there, 1/3. This negative is the one that is in the rule. So this is your 1/a multiplied by the 1/3 that is there. You see? Arc coth of square root of 3 over 2, which is the 1/a inside that coth. Now, inside that arc coth, the 1/a is this one. T is this T that you see here. Now, this T can be replaced by its equivalent, which is tan x. That is what you see there at the end. Now, the equivalence now of this, now which is now minus 1 over square root of 6 and that one, comes when you multiply this by square root of 3 over square root of 3. If you multiply this by square root of 3 over square root of 3, the square root of 3 on top times square root of 3 is a 3. And the square root of 3 at the bottom, multiplied by square root of 2, is square root of 6. The 3 on top divides with this 3 that was there already, and you are left with only 1 over square root of 6, which is this one over there. So it is not necessary for you to do from here to there. I'm just showing you that if somebody gives you an answer as this one, and another person gives you an answer as that one, they are both correct because these two values are equivalent. And in actual fact, this is the simplest version of that. Shall we move to the next question? Are you all happy?
Sir,
Yes.
what if I just use my calculator? Then it's the same
Yeah.
answer, but it's different.
What
Like
is the answer in the calculator?
for example, there negative square root 3 over 3 square root 2.
Yes.
I'm getting negative square root 6 over 6.
Which is the same as this one. If you multiply this by square root of 6 over square root of 6, you get exactly that answer that you're talking about. All of them are correct. You don't have to worry. You can use your calculator. It's fine. It's 100%
Thank you, sir.
acceptable. Absolutely
All right.
fantastic. Right. Perfect. Next question. Guys, do this one. Now, it only has cos squared. It does not have the sine squared. But it is done exactly the same method, same way that we did before. Please, 3 minutes now. I'm counting down from now. Final answer, please. Even if the time is not yet 3 minutes, if you have got an answer, just shout, please.
Answer
Yes, sir.
1 over the square root of 3 arctan into bracket square root of 3 tan x plus c.
All right. Arctan, right?
Yes.
All right. Any seconder? Any objections? No objection, no seconder. Let's check if the answer is correct. Toolkit. There is the toolkit. This is the key to every little problem that looks like this. Replacing things with things on the toolkit gives us that. Cos is 1 over square root of 1 plus tan squared. When we square that, we get 1 over 1 plus tan squared. When we multiply it with this one, they cancel out. It's a 1 that remains here at the end, multiplied by -2. So in the next step, we should get a -2 that is free from from t. But then this one is multiplied by 1 plus t squared. So 1 plus 1 is, sorry, 3 times 1 is 3. 3 times t squared is 3t squared. So here we must get something that looks like this. 3t squared, and then 3 minus 2 is 1. So it should be 3t squared plus 1, the next integral, and then dt, which, I didn't even add them. I just left them as they are, but then 3 minus 2 is 1, as you can see. So our denominator will become 3t squared plus 1. But we still need to factor out this 3. That is where we get the 1 over 3. And when we divide that 1 by 3, we get 1 over 3 before we do this thing. Then when we want to write it in this form, our t squared is already there, plus 1 over square root of 3 squared. This is the 1 over 3 that we had before. Then now you go and look at the rule. Which rule is this one? The rule that says integral of f of x squared plus a squared, or a squared plus f of x squared. That's the rule. Rule number?
Rule 25.
Rule 25.
And you, all of us agree. We all agree. Rule 25. Now apply that rule 25 and let me know what the answer is. Is it that one that was mentioned, or is something else? The answer is that one. So it's arctan square root 3t. And this one came about from 1 over 3 divided by 1 over square root of 3. And dividing by 1 over square root of 3 is the same as multiplying by square root of 3, which gives you that. And also here it has got variations. So you put it in a calculator, you may get this, you may get that, or you may get square root of 3 over 3. You may get 3 over square root of 3, I think, as well. So there are a lot of variations of these answers. Are we all happy with this one? If the answer is yes, then we go to this one. Now I think this one, everybody will be able to get it right. So now it has got an A. Is the first that, the previous one had an A and a B that is equals to 0. That is why there was no sine squared. But here it has got both sine squared and cos squared, and it has got a number 2 there. The same way, same how we do it the same way. There's no difference. Let me share the toolkit as well. Answers, final answers. As soon as you get the answer, please let us know. One minute left. Any answers?
Minus 1 over 3
Yes.
arc cos with an H
Kosh.
Koth.
Koth, or the Kot with an H.
Yes.
Okay.
Into the tan of x plus c.
All right. There we go. We've got the first answer. First correct answer. Any other correct answer out there? Different from this one? None. So let's check the answer. From our toolkit, we can plug things in just to verify that we have plugged everything. 2, come here, there is this down there. Minus 5, there it is. Cos x is 1 over square root of 1 plus t squared, and it is squared, which is that. Coefficient of sine squared is 1, so there's nothing there. Sine itself is t over square root of 1 plus t squared, all of this squared. Now, in the next step, we're supposed to see 2 multiplied by 1 plus t squared, which is 2 plus 2t squared. It has to be there. But also, we will have this one dividing that one after it is squared, and we will have a 5. So we must have a constant of minus 5 as well in our denominator there. This part will have a t squared, and it will have a 1 over t squared at the bottom, which will divide with that one, and we had a t squared there. So this t squared will be added to this 2t squared from this one and that one. So it means we must see a 3t squared somewhere here at the bottom, and then minus 2 minus 5 is a minus 3. So something like that. Let's check if that is the case. So we've got this 2t squared plus this t squared, which is give us the 3t squared that I suggested. And then the 2 minus 5 is a minus 3. That's correct. Then from there, we can factor out the 3 at the bottom. When we factor out the 3 at the bottom, we get 3 into t squared plus 1. 3 into t squared, not plus 1, minus 1. Then that 3 that I've talked about is the 1 over 3 that you see out here. And the t squared minus 1 is this one. You just write it as t squared minus 1 squared so that we can be able to pick a corresponding rule in our list there, which is
29.
rule number 29. Yes, we agree. And according to rule number 29, it becomes that. Because of the fact that now our A is 1 in this case, so there's no issue with the coefficient will be 1 over 3. And it is indeed arccoth, as the speaker has said there, of t. And what is our t? Our t is tan x, and we put it in there, and we get the answer right. Now, this is what should I go back?
Yes.
Yes.
How did you get 3t squared? I've got 2t squared.
How did we get this one?
You see from that one, 1 over 2 plus 2t squared minus 5 plus
Oh,
t.
here.
Yes.
How did we reach here?
Yes, because 2 minus 5 is minus 3.
Firstly, how did we get these values? It is this 2 here that you see here, multiplied by 1 plus t squared. This 2 times 1 is this 2. This 2 times t squared is this 2t squared. Are we happy so far?
Which t squared? Sorry,
This 2 here is multiplying this 1 plus t squared at the bottom of our dx. Our dx, remember, is 1 over 1 plus t squared dt. So this 1 plus t squared multiplies this 2. And when 2 times 1 gives us 2, then 2 times t squared will give us 2t squared. So which is this 2 terms here are from the product of this 2 and this 1 plus t squared. Are you happy with this part?
Yes, sir.
Then this minus 5 has got a 1 over 1 plus t squared. After you square this, you get 1 over 1 plus t squared. And it is multiplied by this 1 plus t squared. When that happens, this becomes a 1. 1 times minus 5 is this minus 5.
Okay.
Then there is this one squared. T squared divided by 1 plus t squared. This gives us t squared over 1 plus t squared multiplied by 1 plus t squared. The 1 plus t squared divide 1 plus t squared, and we're left with only t squared, which is this one.
Okay.
Now this t squared plus this 2t squared gives us 3t squared, which is this multiplied by that. And 2 minus 5 is minus 3, which is 3 times this minus 1, which is minus 3. Are you happy now?
Yes, sir. Thank you.
You're welcome. As I was saying, now we are coming to a question that looks like the previous first slide. The only difference is that here we don't have any powers of 2 on cos and sine. It's just sine x and cos x and sine x. And here, whether b and c are equal, it does not even matter. Even if they are equal, there is nothing we can do about cos x plus sine x. There's just nothing we can do about them. So,
Sorry, sir.
yes, sir.
Before we move on to this one, I just wanted to ask if the coefficients of the two trigonometric functions below are equal, what will happen if you use this method?
If what?
I don't have a typical example of what I'm referring to. I'm just curious to know what will happen. I think is the second, if not the first example.
Okay, let me go back. It's just telling me to stop.
Yeah, no, carry on. Yeah, this one. Yeah, that one.
This one?
Yeah, this one.
This one, okay.
I'm just curious to know what if the coefficients of both sine and cos are the same, what will happen if I use this method?
With this one, there is no way in which if I can put a 2 here, the coefficients are not the same still. Because another one is minus 2, another one is positive 2. So they are still not the same. Because even if you can take out the common factor of 2, if there was a 2 here, you are going to still be remaining with sine squared x minus cos squared x, and there is nothing you can do about them. You can just rewrite this with the same name, maybe sine only or cos only, by using that squared identity. Sine squared x plus cos squared x is equals to 1. And when you do that, you will get a question like this one. It will look like this one.
Okay.
Yes. So the method will still be exactly the same. So what I said when I said that the coefficients must not be the same. So this cannot be plus 3 here and 3 there. Because if that happens, then there is not even an integral that will need anything, because you will factor out that 2 if the positive 2 and the positive 2 there, and you will be left with 2 into sine squared x plus cos squared x, and sine squared x plus cos squared x is 1. So you will have an integral of 1 over 2 dx, which is x over 2, and that's it. So there's no t substitution required if coefficient here and here are exactly the same.
All right. Thanks.
Thank you so much, sir. Thank you so much, sir. We go to that slide, this one. So here it does not matter whether A, B, C are the same or whatever, it does not matter. But the issue is that there is nothing we can do with these two, cos x and sin x. There is nothing we can do. We can only do the t substitution. But now, let me explain something. If we have got that toolkit, we replace this one by 1 over 1 plus t squared dt. We replace this one by t over the square root of 1 plus t squared, and this one by 1 over the square root of 1 plus t squared. When we multiply the 1 over 1 plus t squared in here, it will not remove the square root. So the square roots here will still remain. And if we can try and maybe multiply by the LCM of the denominators, we will have something very complicated here that we will not be able to work with. So whenever you find something like this, and the cos x and the sin x are at the bottom, and they do not have powers of 2, your key there will change. The key will have to change. Now just look at this change, and I will explain to you why it has to be like this. The angle that you choose is not x anymore. Tan is of x over 2, that is equal to t. Now, the main aim here is for us to be able to utilize compound rules for us to be able to replace that cos x and that sin of x with compound rules. That is the reason why we must take the tan of x over 2, not of x. When the powers of cos and sine are powers of 1, and we don't have any powers of 2, it means we must now come up with this plan. Now, our toolkit will change a little bit, not that much. Let's build our toolkit. Our toolkit will come from this triangle. That will be the same. Tan x over 2 is t over 1, which will be the same like that. And then we have our hypotenuse, same way as that. And the same things that we did with our definitions of sine and cosine. But remember, we are doing sine of x over 2 and cos of x over 2. When we do that, we still get the same results on the right-hand side. And then now we do that t equals to tan x over 2, the derivative, to get the replacement of dx. So we will have t equals to tan of x over 2, now dx over dt over dx. When we find the derivative of tan of x over 2, you know that we must find the derivative of what is inside first, which gives us this half. Then the derivative of tan becomes sec squared. And I have made a mistake here. It is supposed to be sec squared of what?
X over
Hello?
2.
It was supposed to be x squared over 2. Let me correct this mistake right now before we continue. This was supposed to be over 2. Aha. And we go back to our slideshow and we reach this. Yes, this was supposed to be the case. Now we need to make dx the subject of the formula the same way we did. So now our half sec squared x over 2 is equals to that. Now it's 1 plus t squared all over 2. This 2 is this one. Now when you flip it over, this one up, this one down, now this 2 will be numerator, this one will be denominator. Then you will get 2 over that, and dx now is that one. Now our toolkit, when we remove dx, it is going to be replaced by 2 over 1 plus t squared dx. And the rest will still be replaced by those ones. But they are going to replace sine of x over 2. They are going to replace sine of x over 2 and cos of x over 2, not sine x and sine and cos x. So our toolkit now will change. Now, this is why I said we are going to use compound rules. Now, our sine of x, according to the compound rules, it's 2 sine x over 2 cos x over 2. If you remember that compound rule for sine of 2a, if it was 2a here, it will be 2 sine a cos a. But now our a is x. Our 2a is equals to x. Now, which means the angles that are here are supposed to be half of what we have on this side. Now, if you go and check there on top, you replace now sine of x over 2 with its equivalent here, and you replace cos of x over 2 with its equivalent there. Then you multiply everything by these 2. The answer becomes that one, 2t all over 1 plus t squared. So sine x is now this one. Now our toolkit also have changed slightly with the presence of these 2 that is there. And then we do the same with cos. Now with cos, it will be a little bit long, because cos of x, if you use the compound rule of cos of 2a, it will be 2 cos squared a minus 1. But now, because our a is our 2a is x, it becomes half of that here. So it is 2 cos squared x over 2 minus 1. There are a lot of versions for this one. It can another version is 1 minus 2 sine squared x over 2. It's equivalent to this one. Another version of this one is cos squared x over 2 minus sine squared x over 2. It's equivalent to this one. But all of them, if you can use any of those, the other 2, you will eventually get to replace cos of x over 2 by its equivalent, which is 1 over square root of 1 plus x squared. And then you get that. And after multiplying this by 2, you get 2 over 1 plus t squared. The square root has gone with the power 2, and 1 over this multiplied by 2 gives you that. Remember, there's a minus 1 that is there, which we have kept there as well. And then now when you add fractions here, you will take the LCM, which is this one, put it down here, and you will say this into the LCM goes 1. 1 times 2 is 2, which you will put there on top. And then here you will be having all over 1. 1 into 1 plus t squared is 1 plus t squared. Times minus 1, it becomes minus 1 minus t squared. Remember, there was a 2 already there, which is 2 now minus 1 minus t squared, which gives you 1 minus t squared there, so that our cos of x will now be replaced by 1 minus t squared all over 1 plus t squared. So our toolkit in summary form is cos of x is equals to 1 minus t squared over 1 plus t squared. Our sine x is equals to 2t all over 1 plus t squared. Our dx is 2 over 1 plus t squared dt. Is there any question here? Any question? None. Then we go straight to an example. I took an example as well that is in the book. It is example 2, and it looks like this. It looks like 1 over 3 sine x plus 4 cos x. And the toolkit now has been updated now, the way I have explained before. Our tan is of x over 2 is equals to t. Our sine x is equals to 2t over 1 plus t squared. Our cos x is equals to 1 minus t squared all over 1 plus t squared. Our dx is equals to 2 over 1 plus t squared. The rest is the same thing that we were doing, so I will not spend much time here. It's about now replacing things now. Sine x is equals to 2t over 1 plus t squared. Because there was a 3 already, that's where we get this 6t over 1 plus t squared. Plus this 4 here multiplies this cos x, and 4 multiplied by 1 minus t squared is 4 minus 4t squared, that you see there. And everything is multiplied by 2 over 1 plus t squared dt, which is our dx. Then this 2 multiplies this 1, and you get this 2 there on top. And the 1 plus t squared multiplies this, and this divides that, and you are left with 6t only, which is that one. And then your 4 minus 4t squared is multiplied by this, and this divides that, and you are left with 4 minus 4t squared, which is what you see there. That this 4 minus 4t squared is from this one. This 6t is this one that is there. And we have got that. That looks very familiar. It's a quadratic expression at the bottom. So if we can complete the square here, if you remember, we did a question, a lesson on that, completing the square here at the bottom. Then we get to reach this step. I will explain step by step. First, at the bottom, there is a coefficient of 2 that we can take out. That coefficient of 2, when we take out, it cancels out that 2 on top. And we've got a 1, which is what you see here. Now, what remains? Hello? Oh, somebody was talking about other things, not what we have here. So the first 2 that we take out from here. Okay, in fact, let's take out 4 as a common factor. 4 as a common factor from the bottom. What we are left with is a 1 here. And when we take out a 4, we are going to divide by 4. So we get a 3 over 2 here. And a 4 that we take out here will give us a minus t squared there. And that 4 that is outside has got a 2 there that says 2 into 4 goes 2. And we've got a 1 on top and a 2 at the bottom. And we take it out as a half, which is this one. I think that way will be much clearer. This half is from the 4, which is a common factor from here, after it divides with the 2 that is there on top. What is left here is 1 here plus 3t over 2 minus t squared. Now we want to complete the square. Now our t squared is negative. So we take here the negative out as a common factor from this one. Remember, here we've got a 3 over 2t, here we've got a minus t squared. We take out a minus sign out, or a minus 1 as a common factor, which is what you see here. That 1 that was created after taking out 4 as the common factor is this 1 that you see here. The minus sign here, if you multiply it inside, you will get back your minus t squared and your plus 3 over 2t. That came out of this 6t when it was divided by 4. So this is that. Then we are preparing now our quadratic for completing the square. Now we complete the square, what is in here. So to complete the square, you will remember that you are supposed to take half the coefficient of t. And what is half of minus 3 over 2? Half of minus 3 over 2 is minus 3 over 4. And you take that one and you square it. You get a 9 over 16. So you add it inside here. You are adding a 9 over 16 inside. Now, this 9 over 16, when you add it as a plus, it is in actual fact a negative, because it has got this negative outside here. So because you have added negative 9 over 16, you must add to 1 a positive 9 over 16 outside. Inside, you added a plus 9 over 16. But outside the bracket, there is this negative sign that applies to everything inside, which means that this is in actual fact a minus 9 over 16. That's why we must add and 9 over 16 to this one, and it gives us 25 over 16. 1 is the same as 16 over 16 plus 9 over 16. The denominator 16. Top 16 plus 9 is 25. So that's where we get this 25 over 16 from. Now we can factorize. This one can be written as 5 over 4 squared. And this one can be written as t minus 3 over 4 into t minus 3 over 4, which gives us t minus 3 over 4 squared after you factorize this one. And now I have already shown that it will be rule number 28 after you have got 5 over 4 squared here minus t minus 3 over 4 squared on this side. Can you just verify if this is correct for me, please? Can you check if indeed it will be rule number 28, which has got an a squared minus f and f of x in brackets squared like that. Is it rule number 28? A squared minus f of x squared.
Correct.
Correct. If that is the case, then we can go on. And now this is the rule that we, this is what I was explaining up here, which is this one. And applying that rule, it will be 2 over 5. Now let's see where this 2 over 5 comes from. Remember, we've got a half that is here. And the rule says 1 over a outside. And 1 over a is 5 over 4. And 1 over 5 over 4 is the same as 4 over 5. So if you multiply half by 4 over 5, 2 will go 2 into 4, and you will get this 2 over this 5. That is where this 2 over 5 is coming from. And it says arctan, tan with an H. Then inside it should be a tan of f of x, which is t minus 3 over 4. T minus 3 over 4 all over a which is 4 over 5, which becomes a which is 5 over 4, sorry, which becomes 4 over 5. That is where this 4 is coming from, and this 5 is coming from. Our t, which was here, is replaced by tan of x over 2 minus the 3 over 4. It is from this bracket here. T, remember, is tan x over 2. Minus 3 over 4 is this minus 3 over 4 that is there. And this is the answer. Here you can even multiply this 4 inside, and you will get 4 tan of x over 2 minus 3 all over 5. And I think the answer in the book is after the inside square bracket is removed. So when you remove this inside square bracket, you get exactly the answer that is in that example 2 in the textbook. So we can do maybe 2 examples here for you to do now. Please do this one. Here's the toolkit and give me the final answer. 3 minutes, please. It's about time up in the next 30 seconds. Can we please start getting answers, please? Any answer? Okay, if no answer is forthcoming, let's do it together. Right, now according to our toolkit, sin x will be replaced by 2t over 1 plus t squared, and cos x will be replaced by 1 minus t squared all over 1 plus t squared, and 1 will remain a constant as it is. Dx will be replaced by 2 over 1 plus t squared dt. Now let's just check my replacement first. This one with 2t over 1 plus t squared, perfect. And now I have got a plus here. Let me just check how this came about. Oh, okay. Now our minus 2 first will be minus 2 into 1 minus t squared over 1 plus t squared. When minus 2 multiplies 1, it becomes minus 2, which is this one. When minus 2 multiplies minus t squared, it becomes plus 2t squared, which becomes this one. That is why here the sign has changed into a plus, because this negative has been multiplied into the cos of 2x for these signs to change. Because here, if you can check, it's 1 minus t squared. Now here it becomes 2t squared minus 2, which means that that minus sign has been applied onto that one. That's why we get that. The plus 1 that was there, here it is. And our dx is exactly as we were instructed to do here at the bottom, which is that one. Now we want to check how this comes about. Straightforward, this 1 multiplied by 1 plus t squared. 1 multiplied by this t squared is this 1 plus t squared at the end. This 2 multiplied by 1, this 2 multiplied by 1 is this 2 over here. Now this denominator divides with this one when it multiplies here, and we're left with 2t squared minus 2, which is this one, 2t squared minus 2. This part is this one on top after this divides that. When this divides that, we are left with 2t, which is plus 2t, which is that one that is over there. So everything is represented after this is multiplied. From there, then we will add like terms. So we'll eventually have 3t squared, because it is this t squared plus that, plus 2t minus 1, because minus 2 plus 1 here will be minus 1. So that, after we get that, we need to have a clean t squared. That is why this 3t squared has got this 3 factored out. When we factor out the 3, we get a t squared here, and this 2t becomes a 2 over 3t, and a minus 1 that was there becomes a minus 1 over 3. That is after we factor out this 3. And we actually even remove the 2, which is this one, which was there outside. So outside is 2 over 3. From this 3 as a factor of here, and this 2 as the one that was there. And here, after factoring out the 3, we get that, which is now ready to be done, the completing of square. Completing of square, we will group this together and leave this one alone outside. So to complete the square here, we must take half the coefficient of t. Well, half of 2 over 3 is 1 over 3. And 1 over 3 squared is 1 over 9, which is what you see here. Now that we have added a 1 over 9 inside here, we must subtract a 1 over 9 from this one. So we'll have minus 1 over 3 minus 1 over 9. And minus 1 over 3 is the same as 3 over 9. So we have got minus 3 over 9 minus 1 over 9, which is minus 4 over 9, which is that one. That's where we got this minus 4 over 9 from. After saying minus 1 over 3 minus 1 over 9, which is compensating for this one that we have added inside the bracket. That's where we got this one from. From there, we will have a perfect square here, squared, minus 2 over 3 here, squared. And which rule is that one? Can you please tell me? Rule that have got f of x squared minus a squared at the bottom. It's rule number
29.
29. Let's check if I am agreeing. Yes, I am agreeing with you. Rule number 29. And now that 2 over 3 is the one that you see outside. This, after being factorized, it becomes t minus 1 over 3 squared. And our 4 over 9, it is 2 over 3, all in brackets, squared. And this is our a, and this is our f of x. And that rule says minus. Now it is only arc cos. Now let's see where is the 1 over a gone to. We already have got a 2 over 3 here, and we are dividing by this a, which is exactly 2 over 3. So 2 over 3 divided by 2 over 3 is 1. Or 2 over 3 multiplied by 3 over 2 if you change the division side to make up a multiplication side. So this and this one cancel out, and now that is why we only have a minus 1 that is left there. Arc cos. And then this is when you have replaced now your t by tan of x over 2. So it is tan of x over 2 minus 1 over 3, which is that one. And this 3 outside, it is from dividing by 2 over 3. It in actual fact is the same as multiplying by 3 over 2, which is what you see there. So you can multiply this 3 inside. This 3 will be giving us 3 tan x over 2 minus 1. When this 3 multiplied by the minus 1 over 3, all of this over 2 plus c. And this is the answer. Now I think you can do this one in 2 minutes, right? Try that one. 2 minutes, please. -2 minutes, this one. It's easy, straightforward, sorting in sin x and cos x and dx and finish. The answer is And answer is?
Answer is,
Come again.
the answer is 2 over the square root of 2 add cos with an h into tan of x over.
Caught with an H, right? Caught with
Yes.
an H. Caught, okay,
Yes.
right? Okay, perfect.
Into tan of x over 2 minus 1 over square root of 2 plus c.
Perfect. Any seconder to this fact? Any objection? Let's check. First is straightforward substitution. In place of sine x, we put its equivalent 2t over 1 plus t squared, which is that one. In place of cos x, we put that one. In place of dx, we put our 2 over 1 plus t squared dt. Now, when we multiply, this 1 over t squared will be dividing all these denominators out, and whatever is left is only the things that we see on top. And the things that we see on top, if we order them properly, they look like what you see here at the bottom. Minus t squared is this one, 2t is this one, 1 is that one. Now, the 2 on top multiplies the 1, and we get that 2 that you see there on top. Now, from here, it's just a matter of doing our completing of square. But because the leading coefficient is negative, then when we isolate, we will start with the 1. That's why you will have a 1 here, and then minus this t squared inside the bracket minus 2t inside like that. This 2 is the one that was there, and it is still here. Now, to do the completing square here, we take half of the coefficient of t, which is minus 1, we square it, and we add it inside. But we are adding a negative value. This minus sign is also for this minus 1. And then it means that the 1 that was outside must be added to another 1 to compensate for this one that we have put inside. That's why this becomes a 2. It was 1 here, now it's a 2. Because if we can remove this bracket, put the negative inside, you will get back here. So this and this are exactly the same. Which rule is this one? If this one can be factorized to be f of x squared, this one can be written as square root of 2 squared. Which rule is this one?
It's 29.
Rule 29. I say rule 28. Am I wrong?
Yes, it's 28, sir.
It's 28.
Yes, because a squared there is square root of 2. So it starts with the a.
With that, with the a. Yeah, yippee. So today I've made only one mistake of that x over 2 so far. So hey, my brain is becoming sharper and sharper. It means that interacting with you make me younger. Right, now next is rule number 28, and the square root of 2 squared is the 2 that was there, and t minus 1 squared is our f of x, and we get this 2 over square root of 2 arctan. It's a tan with an h. And then here it is a tan of x over 2 minus 1 all over square root of 2. Happy? It says we are left with 5 minutes, and this was the last example, and we are done for the day, and have a wonderful evening. Is there any question, comment, or is goodbye? Are we guys happy? Not? A little bit?
Happy.
Okay. Maloba, Mapala.
Yes, sir.
Even though I invent my own
Eh?
box.
Everyone is doing what?
I said even though I had to invent my own toolbox.
Oh. Okay, no, guys, thank you very much for attending as usual. And I see it's almost the same people that are attending. And I'm telling you guys, if you are doing what we are doing together, I'm telling you, there won't be any need for you to study for even the exam. You will wake up and write, and you will surprise Dr. Jamini by getting total in this exam. They will think that you were given the exam. But the thing is, that is how easy mathematics is. You just need to know what you are doing. What you need to know to be doing here, firstly, you must know your derivatives, like your name. Done. When you are doing that, then after that, then it's just a matter of trying to manipulate every integral to suit a rule that is already there, written. It is given to you in the information booklet there. So you just manipulate whatever is given to look like one of the rules. Done. Good night.
Sir,
Night.
Yes.
Is a hand.
are you gonna upload these recordings?
Dr. Lamini is the one that does everything. I'm not even having any powers to create a lesson. So you can see I joined this lesson like everybody else, and I'm given rights. So Dr. Lamini is here with us today. She can tell you where to find these lessons, these recordings.
Okay. And the other thing, I sometimes miss the classes. I found the announcement and link later actually.
You should be the one who worries Dr. Lamini that, hey, I didn't see the link. Where is the link? Every Thursday evening until we finish these things, we will be doing this thing. So we will not skip a Thursday unless I die before next week Thursday or I'm sick. But then you will be notified. So it happens that she's very busy with other things that she's doing and forget to create the link. But you must know that the lesson will be there. Ask her, hey, where's the link? She will create it for you.
Actually, every Thursday we are having a class.
Every Thursday from 6 to 8 until we finish with what I'm doing. Then
Okay.
then the other person will take over from me to do application of integration but the days may change depending on the availability of that other colleague of ours.
Okay.
Yes.
Thanks, I'm answered.
Perfect. Bye-bye. Go guys. Go guys. Thank you, Lilaka. Bye.
Okay, I'm gonna
Go.
stop the recording.
But you wait for them to go. I don't know. I was once told that if somebody is still in the lesson, it will not stop. So I don't know.
That's fine. I have
Ju-
the rights today.
You have got the rights. Perfect. Or you can remove them if they don't go. So I can go
That
then.
they can stay